Following on from the previous video, I will now give you an example of a line integral. So let's say we're trying to work out the area underneath this surface. So we've got a surface here, and we're trying to work out the area underneath this surface along this particular path. So you start at 1, 2. So this is your domain here. 1, 2. So this point here is here, and this is 7, 6, which is this point here. So your particle is moving along like this. It's moving along like this. It's moving along like this. So you've got to set up the parametric equations in such a way that the particle starts here, so at 1, 2, and then each step of the way it moves 3 across, 2 up. So 3 across, 2 up. 3 across, 2 up. So another second later, it would have moved 3 across, 2 up. So that means the horizontal distance of 6. So that's why from here to here is 6. You can see 1 to 7. So this distance is 6. And then the vertical distance is 2 and 2. That would be 4. So that would take you to from 2 to 4. Well, somehow drive your particle so it moves along in this direction here. So that would be, well, your parametric equations would be given by this, and we've done this before. I'm expecting you to know it. So we're trying to work out this area here underneath this surface. We're trying to work out this area. So the particle is moving along. When time equals 1, the particle would be here, which equates to the particle being here. So once the particle is here, you would then put the x and y location, into the surface, then it would jump to the surface. So basically you're trying to work out this area after 1 second, and then another second later the particle will move along and it will end up here. So it will end up here, and then you would put the x and y location of that particle into the surface, and then that would then jump to the surface, and then you're trying to work out this area here, and then you sum up the two areas. Well, anyway, let's start again here. The line integral is given by this, which was shown in the previous video. So you remember when you put x and y into the function, it has to be in terms of t. So this is a bit like some sort of function. I'm just going to call it g of t. Everything is in terms of time. So you're using this thing called time to drive the particle along. Let's say the particle is here at t equals 1. Then you always know the x. You always know the x and y location. So you would really put this into here. So it would then be 1 plus 3t squared, because this is the x location. You see, you've got to put everything in terms of t and not in terms of x and y. Even though this is expressed in terms of x and y, you've got to put everything in terms of time. So here the y location in terms of time is given by this. So you can imagine this as being h of t. Well, what that means is, what is the y location of this particle? So you would put this into the y. So that would then become 2 plus 2t squared, because the function here says square the x and y location. And then hang on, I think I've made a mistake somewhere. Hang on, let me think. Okay, so I'm going to change this to a 3. Hang on, bear with me. I'm going to change this to a 3. Okay, so hang on. So what this is saying is, puts the x and y location all in terms of time into the surface, and then in order to work this out, we've got to work out the speed. This is the magnitude of the velocity. So hang on, we've got to work out the magnitude of the velocity, hang on, bear with me, I've lost track. So we would put this into here, square it, put this into here, square it. That will then give us this x squared y squared plus 3. I made a mistake earlier by saying this was 1, but it should be a 3. So this is a 3. So that will then take us to here. That will then take us to here. But then we need to work out the speed. So the speed would be you going back to here, So you've got to find dx by dt, and then later on, so dx by dt is 3, and then dy by dt is 2. So that's this bit here. So 3 and 2. And then don't forget, you've got to square it. So when you put this into here and square it, it would then become 9. And then put this into here and then square it. That would then become 4. And then so that this whole thing here will be square root of 13. So so what goes in here? What goes in here is the square root of 13. Now square root of 13 is a constant, so you can take it out of the integral. So it will then become this. And don't forget, as the particle is moving along, it's moving along from time equals 0 to time equals 2. So the line integral is given by this whole thing here. So it's just a matter of tidying this up. So when you square this, it will then give you this. When you square this, it will then give you this, and then you've got your constant there. Tidy this whole thing up, it will then become this. So tidy this whole thing up, it will then become this, and then integrate it with respect to time from 0 to 2. So when you integrate this whole thing, it will then become this from 0 to 2, and then now it's just a matter of plugging in 2 into here, 2 into here, 2 into here, take away 0 into blah blah blah. It will then give you this. So the area underneath that surface in this particular path from here to here, so this area here is given by this. Okay.